This was the Space Shot. It's an amusement park ride. So in part A, we found the Space Shot changed directions at times 6, 8, and 10 because that's where the velocity was 0 and the velocity changed sign. At what time is the Space Shot the highest? This is a closed interval, so we're going to do the candidates test. And we said we're going to let y of t equal the height of the ride. So in each of these, what you're actually doing is you're going to go from 0 to 6 of the integral v of t dt. Well, what that means, I have the graph of v of t, so I have a trapezoid here. So what I want you to do then is I want you to go ahead and find the area from 0 to 6. I'm going to pause and give you 2-3 minutes, and then I want you to do time is 8, so then you're going to subtract the time from 6 to 8, and then you're going to do to 10 and then to 14. All right, did anybody get for 6? Anybody get it? What'd you get, Walter? I didn't get 5.
Oh,
yeah, oh, did you catch? Oh, so guess what? If you got 5, what is it then? 100. There you go. All right, then to do the next one, 0 to 8, all you have to do then is you're going to subtract off that piece and so on. So let me pause and let you work that out. So Elizabeth, what did you get for time 8 then? Yeah, that's what I got as well. All right, keep going. Then to get to 10, you're going to take that number, okay, and then just add in from 8 to 10. Kai, did you get 10? 80. There we go. And how about 14? Skylar, did you get to 14? Good job. All right. So how high? So which one is the maximum? At 6. Okay. So t equals 6. And it's a maximum height of 100 feet. And this was at 6 seconds. There we go. All right, to find the total distance, and remember on the chart we looked at yesterday, to find the total distance, I'm going to go the integral from 0 to 14 of the absolute value of velocity. So make sure, like if this were a free response, you would get 1 point for this statement. You can still get the right answer, but you'd only get 1 out of the 2 points. So then all I have to do is add those distances, and it's 280 feet. Oops, sorry, did I add the wrong thing? I did, hold on. Sorry, whoops. Got it. So you have from 0 to 100 is 100. From 100 to 40 was 60. From 40 to 80 is 40. And then from 80 to 0, there we go. Now letter D, write an expression for the ride's acceleration. Well, isn't acceleration the derivative of the velocity? Now this is also asking me for acceleration, velocity, and distance for the time interval from 10 to 12. So I don't have an equation. Let me go erase what I drew on here. And from 10 to 12, isn't this a line segment? Isn't that a line segment? So then what would be my derivative there? I'm down 40 over 2, so my acceleration is negative 20. And that would be feet per second squared. Now if I want the velocity from 10 to 12, isn't the velocity a line? That from 10 to 12, isn't that velocity represented by a line? So to do this, we could actually use point slope. And I'm just going to randomly choose between 10 and 12, 10 comma 0, because that's the nicest point. And then watch what I'm going to do. And then I've got t comma v of t is my second point. So I'm going to do v of t minus 0 equals, now isn't the slope the acceleration, times t minus 10. So then I can just solve that, and I can either leave it like that or distribute, doesn't matter. Then if I want the distance, now we did call it y of t above, but I'm just going to call it s of t. I don't know its position at s of 10, so I have to state that. Plus, I need the accumulated change from 10 to whatever time of my velocity. And then I do need to change it to some dummy variable. And so I could, in fact, tidy that up because we found our v. I hit it on the side sometimes and the whole thing runs. All right, so this example 2 is outstanding practice for free response. Okay, free response style. This could be like a whole 9-point problem. All right, now I'm going to give you a couple of minutes, and I want you to try. Example 3 has 2 multiple choice questions. It says choose the expression. So you're not actually going to solve anything. I just want to know what would be the setup. So go ahead and try multiple choice question 1 and 2. Circle the answer. Think about it. take 30 seconds. Discuss at your tables. What did you get? Yeah, do both. Do both. All right, let's look at the first one. A particle moves in a straight line with velocity v of t meters per second, where t is the time in seconds. At t equals 5, the particle's distance from the starting point was 6 meters. What is the total distance the particle has traveled? So which letter did we choose? This would be C. And we did this up here in this part C. That was the total distance, is the absolute value. All right, number 2. A particle moves in a straight line with velocity v of t equals t squared minus 3t minus 7 meters per second, where t is time in seconds. At time t equals 2, the particle's distance from the starting point was 10 meters in the positive direction. What is the particle's displacement? Is it asking me for the particle's position? No. It's asking me for the displacement. So which letter choice should this be? B. This should be B. I don't need, part A tells me the position at time 9. But if I want displacement, that's just the net change. That's just the net change. All right, example 4. It says the position of a particle moving on the x-axis in feet from the origin is given by x of t. The velocity of the particle in feet per second is given by v of t, and the acceleration a of t. For each of the integral expressions given in the following table, interpret its meaning by filling in the missing noun, appropriate units, and or the correct time value or interval. So let me give you about 3 minutes, and I want you to fill in as many of these as you can. Well, let me do the first row, just to give you what I mean by this. So x of 2 plus the integral from 2 to 4 of x prime of t dt gives me the position of the particle. So this would be in feet from your origin. And the time is at 4 seconds. All right, now you try the rest of them.
Because I don't have my starting point. So do you see, this is telling me your position at time 2, plus this is the displacement. So this is just, right here is just the displacement. It's not telling me my final location. It's just telling me between 1 and 4 seconds, how did I change position.
So I put the second row up, you can check it. So today our period is done at 9:35, and that's when I'll put kicking it up. the third row, did you get average speed? Average speed of the particle? All right, when you're ready, here's the rest of the table.